For the past 2 years, AI research tools operated on a simple mechanism: upload a static PDF, ask a question, and extract a summary. The 2026 update to Google NotebookLM shifts this process from a retrieval task into a computational one. The platform has undergone a complete teardown and reconstruction of its underlying system architecture. NotebookLM now functions as a fully integrated computational environment rather than a passive document reader. To understand how this works, we need to map the exact flow of data through a new 4-stage processing pipeline. Information now travels through data ingestion, into core processing, out through multimodal generation, and cycles into knowledge retention. Converting a system from text prediction to data processing requires a total rebuild of how raw information enters the model. To grasp the utility of automated research, we need to follow the exact movement of data through this pipeline. The first node is data ingestion. In early iterations, requiring users to manually drag and drop files created a severe bottleneck, limiting the AI to a specific moment in time. The system now bypasses this friction using live sync for Google Docs and Google Sheets. Instead of manual updates, the AI maintains an unbroken data feed to your external workspace files. Modify a Drive spreadsheet, and your context window updates instantly. The platform also natively handles EPUB formats, processing complete digital books. A more significant engineering shift in this phase bypasses personal files entirely: the idea prompt. When given a single question, the AI transitions to autonomous action, scraping the open web to discover, extract, and compile relevant sources on its own. This removes the requirement for users to pre-gather all research materials before engaging the system. The ingestion phase operates as a live, autonomous feed, pulling raw data into the system so the analysis can begin. Once the data is gathered, it hits the second stage of the pipeline, the processing engine. This core runs on the Gemini 3.5 model, supported by the anti-gravity infrastructure. Anti-gravity provides a measurable reduction in hallucination rates when the model is forced to analyze highly dense technical or academic material. Standard large language models are built on probability, making them unreliable for complex mathematical modeling or precise data sorting. To solve for this, NotebookLM embeds a secure cloud computer directly inside every individual notebook. Within this isolated sandbox, the AI can natively write and execute actual programming scripts, running Python on your data to generate precise outputs. If you ingest a complex financial spreadsheet and ask for the variance between 3 columns, the AI writes a background script to calculate the exact variables rather than guessing. This capability bridges the gap between qualitative text analysis and strict quantitative data processing. The scripting and execution happen behind the scenes, requiring no programming knowledge from the user. The model now performs its analysis through deterministic logic. Process data requires distribution. This brings us to the third pipeline stage, output generation, managed by the Studio panel. The Studio panel treats generated media as algorithmic modular components, rather than static one-off files. Take the slide deck generator. Using a feature called Pencil UI, you can use text prompts to isolate and edit exact elements on a specific slide. This allows you to rewrite a single paragraph or alter the styling of one specific slide without regenerating the entire deck. For professional portability, these decks export directly into fully editable Microsoft PowerPoint formats. For visual communication, the system integrates the VN3 model to generate cinematic video overviews, translating heavy research into visual explanations. Render a 60-second summary, export sources into Markdown, generate Excel spreadsheets, or interactive mind maps. The Studio panel provides programmable media that adapts to the researcher's specific requirements. The final stage of the pipeline moves away from machine output and focuses on human learning, knowledge retention. Deep research often spans weeks or months, creating a continuity problem when projects are handled across multiple sessions. NotebookLM addresses this with persistent chat history, maintaining the conversational context and continuity between different sessions. To assist in moving data into the user's long-term memory, the platform generates flashcards and quizzes directly from the source material. These tools feature active state tracking. As you review a card, you categorize it as understood or missed, and the system routes them accordingly. Using spaced repetition logic, the system isolates the concepts you missed and continuously cycles those specific cards back into your future study sessions. The architecture processes the data and then engineers the user's long-term retention of that material. Processing proprietary data through this pipeline requires strict digital boundaries. Intellectual property and professional privacy are the primary constraints for an enterprise tool. Google maintains a policy that uploaded user data and files are strictly ring-fenced and never utilized to train generalized AI models. Supporting autonomous scraping and code execution carries significant computational costs. To manage this, Google introduced the AI Plus subscription tier at $4.99 a month. This tier provides the general public with access to the core computational sandbox and data synthesis features. High-bandwidth features, specifically advanced Veo 3 cinematic rendering, remain gated for Ultra and Workspace Business subscribers. The 2026 iteration of NotebookLM replaces the concept of a static document chat with a multimodal computing ecosystem. This system defines the modern research workflow as the orchestration of a live, autonomous computational environment.